10.8, combinations and permutations. We're going to be doing a lot of this in class and a lot of practicing this stuff in class, but you need to know a couple things before we can practice or learn anything else. So let's say for dinner you have a couple choices. For the main dish you can choose steak or vegetable lasagna. For a side dish you can choose rice, potato, or garlic bread. And then for dessert you have pie or cake to choose from. How many different combinations are possible? Well, we learned the other day that a factor tree is a great way to organize your data and to make sure that you end up with every possibility. So we have main dish first, and then we have a side dish that we can choose from. And then for dessert, we can either choose cake or pie. So main dishes, let's have steak or lasagna. These are independent of each other, so my sides could be rice, potato, or garlic bread. And same thing if I choose the vegetarian lasagna. Rice, potato, and garlic bread. And then finally, for dessert, I have cake or pie. And it doesn't matter what I've chosen before this, I still have cake or pie to choose from. So, lots of C's and P's. And then let's count them all up. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different ways that this can happen. Take a look back up at our number of things. We had 2 choices for a main dish, 3 choices for a side dish, and 2 for dessert. Is there any way we could take those 3 numbers and turn them into 12? Well, hopefully you said multiplication. We had 2 side dishes, 2 main dishes, 3 side dishes, and 2 desserts. So that gives us 12. There's actually a rule that states this because mathematicians don't sit around making diagram tree things all the time. It says if there are m ways to choose a first item and n ways to choose a second item, then there are m times n ways to choose both. This is called the fundamental counting principle that says all we need to do is just multiply our number of choices together. So let's say that we have a voicemail system password. We have to have 2 letters followed by 2-digit numbers. There's no way I want to make a factor tree about this. It would take forever. But we have some rules. We have letters. We have to have 2 of them. And then 2 numbers. We know we're going to end up multiplying whatever numbers we get together. So then we have to think about how many different ways that these things can happen. So how many different letters do we have to choose from? 26. And then it doesn't say anything about not being able to repeat things, so we're going to assume that we can. So we have another 26 options for the second letter. And then numbers. Our numbers, we can make 1, 2, 3, 4, 5, all the way up to 9, and then 0 needs to be included also. So we have 10 different choices for numbers. And again, it doesn't say anything about not repeating, so we can. If you multiply 26 times 26 by 10, you end up with 67,600 different possibilities for passwords. That tree would have taken us forever. So now we have 2 different kinds of events that we want to focus on. You can either have something called a simple event or a compound event. Hopefully we are all good at finding probabilities for simple events, but the compound event is a little different. So a simple event is just one thing. Rolling a 4 on a number cube, that's something that I want. Flipping a coin and having it land on heads, one thing, one option. Spinning red, same thing. A compound event is a combination of 2 or more simple events. So rolling a 2 and flipping tails, 2 different things. Spinning red, then spinning blue, 2 different things. Choosing chicken and then rice and then pie, that is 3 different things, but it's still a compound event. In those compound events, we can order things in 2 different ways. We can order things in a combination or a permutation. Now, combination is a grouping of outcomes in which order does not matter, which is very strange because chances are you guys all know a combination. You haven't memorized. It's your locker combination. Doesn't matter what order your locker combination is in. You better believe it does. If you have those same 3 numbers and switch them around, your locker will not open. But mathematically, a combination is when order does not matter. So an example, how many different ways can you choose a main course, a side dish, and a dessert? I don't care which one you eat first. I just want to know how many possibilities are there. Order does not matter. A permutation, on the other hand, is a grouping of outcomes in which the order does matter. So it's like your locker combination. So how many different ways can you string a cubical, spherical, cylindrical bead on a necklace? Well, you could do the cube, then the circle, then the cylinder. Or you could do the cube and then the cylinder and then the circle. You can move them around and it matters which one goes first. So we're going to focus more on combinations and permutations in class because we need lots of practice with that. But we have one last thing to talk about, something called a factorial. So how many different ways can the numbers 1 through 9 be placed on a row of a Sudoku puzzle? So if you guys have ever played Sudoku, you cannot repeat the numbers. Numbers go from 1 through 9, so you have 9 different options. So in the first spot, how many different number choices do we have? We have 9 possibilities. And then we've used up one of those numbers. It can't repeat. So we have 8. And then we have only 7 left. And you guys have hopefully picked up the pattern. We're going to keep on going. 4 times 3 times 2 times 1. Once you've put in 8 of those numbers, you only have 1 number to put in the last column. So you only have 1 possibility. And this right here, we can multiply all these together. And we end up with a huge number again. 362,880. So that is how many different ways that they can put a Sudoku row in place. And Sudoku has a couple rows, so it's a ridiculous amount of Sudoku puzzles that we can create. This type of math procedure, again, mathematicians have a simpler way to do. We often use it in statistics and then definitely in probability. We'll be using it in combinations and permutations. So because we use it all the time, we define it as an actual operation. 9 times 8 times 7 all the way to 1 is an operation. And it's called the factorial of a number. And it looks like an exclamation point. So this isn't some number really excitedly. This is n factorial. And this is the mathematical definition. And it's basically what we just did. You take whatever your starting number is. So ours was 9. And then you do 9 minus 1, and that's where we got 8. And then 9 minus 2, and that's where we got 7. 9 minus 3, that's where we got 6. And you keep on going until you get to 1. So if I want to do some practice with this, 3 factorial, 3 times 2 times 1 is just 6. 5 is 5 times 4 times 3 times 2 times 1. So that gives us 20 here, and then 6, and then 1 just doesn't do anything. So 20 times 6 is 120. 1 factorial is just 1. And 0 factorial is quite weird. 0 factorial is just 1. It's kind of like the weird, like x to the 0 power gives us 1. Same sort of justification for why 0 factorial is 1. You can find this on your calculator, so you don't have to type all that in. If you go to the math button, there's a probability. It says PRB. Find the exclamation point, and that's what you can use. So I'll show you that tomorrow, and we can do it in our graphing calculators without writing it all out. So it's useful if we ask questions like these last two that we have here. How many ways can 3 people stand in line? So you have this line, and spot number 1, you have 3 people. So we have 3 different people that can stand there. Now one person has already stood in that line. So then we have the second spot. Now there are only 2 people that can stand in that spot. And then the last person in line is already determined because there's no one left. So instead of saying 3 times 2 times 1, we could just say 3 factorial, which is 6. How many ways can you arrange the letters M-A-T-H? So same idea. We have 4 letters to choose from. In the first spot, I have an M, an A, and an M, an A, a T, and an H to choose from. So I have 4 different letters. Then I use one of them, and now I only have 3. And then I have 2 left. And then finally, whatever's left over goes in the last spot. So 4 times 3 times 2 times 1 gives us 24. And that's all you need to know for class tomorrow. We're going to do stuff with permutations tomorrow, and then eventually we'll get to combinations. Have a good night.